Hello everybody. Today we're going to go over a sneak peek to this next programming project, the Major League Baseball players. This is one of the harder assignments in this course, so don't worry if you might see yourself spending like an hour or two on it. This assignment introduces data science, where we take in large amounts of data and learn from it. At the beginning of this course, week 1, we briefly talked about computer science and applications of your future career. In this case, we're going to be somewhere over here. Basically, we'll be doing statistics and computer science. That's really what we'll be doing. Okay, but yeah, I'm showing this picture because nowadays AI is kind of a popular term, and to formalize it a bit, this diagram kind of does a good job at it. It's showing the overlaps between all of these topics. So we're pretty much going to be doing statistics. It's going to overlap with a bit of data science and computer science. So that's what we'll be doing today. All right. Before we jump into this programming project, I want to bring a more simplified scenario. So I'm not even going to download this notebook yet. Let's at least make sure we understand this different scenario first, and then you can probably apply it to this next programming project. A couple days ago, we ended off on the algorithms lesson, and at the last 15 minutes of that class, we introduced this data structure right here. Let me pull it up. Here's the algorithms lesson. We ended off on a data structure. In this case, we have like a hard-coded list of dictionaries that kind of stores people's profiles. These are just some random names here. I'm going to go ahead and copy this and work with this data structure so people kind of get a sense on how to do this next programming project. I'm going to create a brand new notebook for this. So let me go back a directory, go into my examples. I'm probably going to create a new file for this, a new notebook, I mean. So I'll make a new notebook here. A good name for this is probably going to be like data statistics, because I'm just going to be using this data structure and performing some algorithms that goes through it. Okay, this is a simplified version of what the assignment is. The assignment is going to be dealing with large data, but the data really looks like this right here. It's a list of dictionaries. So dictionary 1, 2, 3, 4, and then 5. Just to kind of play around with this data, we look at the data here. Oh, I forgot to run the first cell. Oh no, I did run the first cell. I just named this variable wrong. So this is grades. Grades, if we were to print it, we see that it's a list of dictionaries. It's kind of hard to read when it's printed here, but yeah, we have one dictionary here, another one here, and yeah, in total there's 5 of them, because if we print the length of all the grades, we get 5, meaning this list has 5 dictionaries. Okay, let's practice navigating this. By now, we should be comfortable with for loops. If we were to write a for loop that iterates over this sequence, what do you think each element would be? Let's find out. I'm going to say for something in grades. Let's print something. Okay, let's kind of see what's going to happen. Grades is a sequence. And something, this is a variable that represents every element in the sequence. So if we go ahead and print it, we see that each of them are dictionaries. And just to prove it again, this is the type is a dictionary. A good name for this something variable would probably be like profile. This is a little readable because each element in this grades list can be described as someone's profile. Okay, let's go ahead and practice. Let's keep navigating this. So I'm gonna go ahead and print some equal signs here because I'm planning on making things a little neater here. Let me print out like 40 equal signs. Separate things, make it a little nicer. Okay, these are dictionaries, meaning that we can index into it. Profile is a dictionary, and we can index things like name or grade. In this case, if I were just to print name, let's see, key error. Oh, I gotta use a lowercase, my bad. It's case sensitive, so lowercase there, and we're accessing each name here. We can also access the grade. Every dictionary has a grade key, so if you wanted to print it, then you could print out the I'm gonna put this in an F string actually, just so it looks a little neater. Okay, I'll put this in an F string and I'll say this person's grade is, and then I'm gonna go ahead and put their grade value here. Okay, so let's play this. Okay, great. So we're iterating the dictionary, and for each iteration, we're pretty much accessing these two values. Okay, people cool with this so far? Cool with this? All right. Stick with me, because this is gonna build up to the next programming project. All right. Sometimes it's necessary to calculate statistics from data sets, because this will maybe help describe what the data is, or maybe you can use those results to predict the future. We're not really going to be predicting the future in this class, but if you go further into computer science, you might find yourself in an AI or a machine learning class. And in those types of classes, there's a chance that you'll be designing algorithms to maybe predict the future. So predicting the future requires a bit of statistics, where you go through a lot of data and kind of analyze things. For here, let's keep the scenario basic statistics. Like, say we want to calculate the average grade. So in order to calculate the average grade, we'd have to add up all the grades and divide it by how many people there are. People cool with that. So let's go ahead and calculate the average. We do have to accumulate all of the grades together. So one way of doing this is by declaring a variable that accumulates that. So I'll declare a total that represents an integer. This is the numerator, and later on we're just going to divide by how many people there were. So in the for loop, we do have to accumulate everyone's grades, add them up. So I'll say total here. Okay, cool. So this should add up all of the totals. And before we calculate the average, let's just sanity check this value. Total is, once again, it's a good idea to sanity check variables along the way, because you don't really want to type out the whole solution and then test it. Otherwise, it might be hard to debug if things are going wrong in the middle. So I'll press play here. Okay, total is 307. That looks about right. It looks like the sum of all these numbers. Great. Now that we sanity checked the total and our code is syntactically correct, we can go ahead and calculate the average. The average is the total divided by how many students there are. So I'll create a variable called average, and equal to the total divided by how many students. I wouldn't really hard code a 5 here. You know, this would work, but it's probably better to represent it as the length of grades. Length of grades will tell us how many items are in this list. So once in the beginning we saw this was 5. This is better because our data set can change. So if the data set changes, then this will still work. Okay, so I'll press play here. I mean, no, I won't press play yet. Let me print out the result. Average grade is average. And let me put this in an F string again. Okay, press play, and let's sanity check. So boom, 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 and then average grade is 61.4. Okay, yeah, this seems about right. Let's keep sanity checking it. I'll probably change some numbers here. These are hard-coded numbers, but I'll go ahead and change some things. Like let's say Bob here got a 50 here instead. This should raise the average. Okay, I'll load this back in, press play here, and we should see the average get higher. Great, we saw the average get higher, 71. So yeah, it looks like it's good. Okay, people cool with this so far? We calculated the average. The tricky part of this algorithm is kind of navigating this data structure. Okay, let's continue. These print statements are kind of just debugging statements. I don't think we need them too much here, so I'm going to comment them out. They're really just to visualize each step of the way. So I'll comment them out so our output looks a little cleaner. Okay, so there you go. We calculated the average. Some other statistics problems would be, you know, maybe finding the high score, or maybe finding who got that high score. We saw how to do this last week in the lab over here, lab 17. If you did lab 17 and finished this one in particular, number 2, yeah, you should be good for this. So basically, let's implement that algorithm to find the highest score. Like, let's say that our last print statement says something like high score is something. I don't know what it is yet. Well, actually, we do know what it is. That the highest score is 100 here. So you know, you could put 100 here, but hopefully people will see that this is kind of not appropriate because the data set could change. It would be better to calculate the high score and then print it here, because the high score is a variable. So in this case, it might be useful to have a variable called high score. For now, I'm going to initialize it in the beginning as 0. The reason why I initialize the high score to 0 is because we're going to end up trying to find a bigger score. In the beginning of the algorithm, we don't know its high score yet. So it would be a good idea to initialize it to 0 because this is the lowest possible score. And we can search all of the profiles to see if they beat this high score. Once again, this is stuff from a couple days ago. You can take a look at the last video. We talked about a high watermark algorithm. So yeah, take a look at that. If anything, we need to find a bigger score. Currently, if I were to play this, it says high score is 0. It should print 100. So yeah, we need a condition. There is some condition where this high score needs to get updated. And that high score is, you know, if the current grade that we're looking at is greater than the high score. People see what I mean? This is saying if we beat the high score, then we got to update it. Yeah, people see what's happening here. So this is, yeah, it's saying if we found a bigger grade, then the high score would change. So let's Let me do a print statement in here. You don't have to, but it'll help us visualize what's going on. This print statement here will say like found a higher score. Just so we can trace through this. And you know, I'm gonna uncomment these as well. So we got a bunch of print statements. All right, let's test it. So the algorithm starts at 0 for the high score. The for loop looks at Alice's grade, sees as 90. So 90 is a higher score. So the high score becomes 90. Okay, and then the for loop goes to the next profile, to Victoria, and 100 is greater than the current high score. So found a higher score, and then it gets updated again. But then these next people, their scores are not greater than the current high score, so it stays the same, and then so on. Just to verify this, if we were to change this data set, like maybe let's say David for some reason got like 470, just for some reason, change the data set a bit. Let's check this. So I'll press play here, and there we go. This makes sense. 90 beats 0, that's fine. 100 beats 90, that's fine. 50, that's not greater than 100. 70 is not greater. 470 is greater. Found a higher score. And yeah, the high score is 470. Perfect. People cool with this so far? So we're kind of combining some algorithms here. We're going through a data structure, and so far all we did was calculate the average and the high score. All right, any questions about this so far? Okay, hopefully people are cool with this. Let's let's change the scenario a bit. You know, I'm gonna comment these out again. I don't want too much text here. Comment out this. Okay, cool. And you know, I'll change David back to 47. Okay, great. Let's say we wanted to find who got this high score. This is a number, but maybe we want to associate this number with whoever got it. With our current design, there's no way to print the person who got this high score. Like if I were to modify this print statement and say high score is this number from some person. Right, let's say I put some person here. Well, we don't know what to put in here yet because we never kept track of who got this high score. So if you wanted to keep track of that, it might be necessary to make another variable that represents who got this high score. In the beginning of the algorithm, we don't know who got it. So maybe you could say high score person. This is a string. This is going to be a string that represents who got this number. You know, in the beginning of the algorithm, we don't know. So I'm actually going to initialize this to IDK because the algorithm doesn't know yet. But when the algorithm goes through these profiles, if we find a higher score, then we should update this string. So let's do that. If we found a higher score, we'll update the number and the name of the person who got that score. So profile name, perfect. Okay, so yeah, now we're keeping track of two variables. This is a number and this is a string. So I'll go ahead and put this string in this print statement. So let's press play. And we see that the print statement got updated. High score is 100 from Victoria. Cool, that looks good. Let's keep testing to make sure our algorithm is good. Like let's say Jim got like 101. Jim got an extra credit point for some reason. So let me reload this. Okay, cool. I just reloaded this list. of dictionaries. And then if I press play here, it should be a different person. So let's see, press play. Perfect. It looks like our high score algorithm is working. People cool with this? People cool with this? If you're cool with this, then the programming project will be kind of smooth. Okay, sounds good. Yeah, so this is pretty much a simplified scenario of what the programming project is. Let's go ahead and pull up the project. I'm gonna download it. Okay, here it is, Major League Baseball players. Let's download it. Let's see. Oh, hold up, I need to do something. I gotta enable something. Give me 1 second. Okay, Major League Baseball players. Publish. Okay, should work now. Okay, download. Perfect, downloading. Let me upload it to the server. Let's see, projects, create new folder. Okay, project 12. And then get this here. Okay, great. I'm gonna go ahead and quit all of this tabs. Okay, here's our notebook. Once again, this project is one of the harder ones in this class. The reason why is because you might have a lot of room for logical errors. You'll see what I mean in a bit. The point of this project is really to do statistics on a large data set. And the data set lives in our lessons directory. So it's over here. Here, I'll pull it up. I'll pull it up real quick. So in our lessons directory in the files, there is this Major League Baseball players .csv. .csv means comma separated values. This is typically a file you would get if you were to download a file from Google Sheets or Microsoft Excel. So this file here looks like a table. It's actually comma separated if you look at the actual file, but Jupyter Notebook is representing it as a table here. We can see that each row represents a person, and each column represents a feature of that person. The height, weight, age. This is the Major League Baseball players. It's a pretty old data set, but it's got like a lot of people here. Let me just keep scrolling. San Francisco. See, here's the San Francisco team. We got all of these people here. Yep, that's how big the team is. And then now we have some more people with different teams. So yeah, this is pretty much the data set. Pretty much the project is to take this data and calculate some statistics from it, like finding the average of some feature, finding the person with the smallest feature, or the opposite, finding the person with some big feature. Okay, let's go to the notebook and unpack what's going on. Let me see. Folks can read this stuff later. It's pretty much introducing what this stuff is. Let's see. Yeah, so this stuff is pretty much saying the point of this project is to pick your favorite team and in that team calculate some statistics. The statistics is going to involve something called body mass index. You don't have to worry about this right now, but as long as you get what we're about to do. But basically, we're going to iterate through a team and calculate statistics. That's it. Okay, there's the code cell here, which pretty much loads the data in for us. So you don't have to worry about opening this file up and bringing it into Python. This cell pretty much does that for us. It's saying, hey, open this file and store that file into a list of dictionaries. That's what it's saying. If you want to put a comment here to better understand this, data is a list of dictionaries, or data will become. That's pretty much what this cell is doing. And then down here, this is kind of just showing the first element of the data. So let me load this cell in real quick. Press play. Okay, great. Here we are. The first print statement is saying, hey, the first row is this. And then this first row is a dictionary. Very similar to what we saw earlier with the grades scenario. This is a dictionary, but it has more key value pairs. This is the first row of the data. It's pretty much this over here, this first row. And the dictionary represents each feature: the name, team, position, height, weight, age. So yeah, just sanity checking things. And then here, the second print statement is going into the dictionary and grabbing the value associated with name. That's pretty much what it's doing here. Okay. So yeah, this part is done for you. Let's go ahead and navigate this data a bit. So, I'm gonna create another cell here. I'm gonna practice navigating the data, and then throughout that, we'll explain what this homework is asking for. All right, let's make sure you're familiar with how this is laid out. So data is a list of dictionaries. Just to prove it, if we were to print data here, there's a lot. Oh, it's actually kind of hard to read. It's actually pretty hard to read because of the formatting. But yeah, it's a list of dictionaries. It's like what we saw in the very beginning of class. Let's verify the length of the data. The length of the data should give us how many players there are. And there are 1,033. Okay, let me sanity check this to make sure. So this means there should be 1,033 rows. So row all the way to the bottom, and 1,033. Perfect. It looks like our dictionary is the correct size. Okay. Let's practice navigating this data. So it's going to be just like the previous notebook. I'm going to use a for loop here for something in data. I'm just going to go ahead and print something. Once again, this is a for loop. Data is a sequence. Every element is a dictionary. So if I were to print this something, we see that it prints everything here. Let me print some new lines here. Not new lines, equal signs. Okay, just so you can read it a little easier. So yeah, what's a better name for something? It's probably profile again. I'm gonna rename this to profile. Press play again. There we go. So yeah, data is a list of dictionaries. Each dictionary is represented by this variable name profile. And yeah, there we go. We're just kind of printing things out. All right, any questions about this so far? Okay, there are quite a bit of lines here, by the way. There's probably like 2,000 lines in this. So I'm actually gonna quit this. I mean, not quit, clear the output here. clear the cell output. Sometimes it might be necessary to filter things. Like, what if we only cared about people that are in a certain team? Well, each dictionary does have a key value pair that represents the team they're on. So if we wanted to only focus on the people we care about, then you could write a condition. You could wrap this whole thing in condition that says, you know, if the profile is in that team, then we can do stuff with it. So in this case, I'll say profile team, because team is a key in each dictionary. So in this case, I'm only going to care about the SF team, San Francisco. So this is saying if the profiles team is SF, I'm gonna indent this right here. This way it belongs in the if statement. So tab, boom, indented. So we should get a lot less print statements now. Press play, and let's verify. Yeah, it looks like we're getting a lot less print statements. Before there was like 2,000 lines, and there's a lot less here. Here, let's sanity check this to make sure we're all good. So the first person here is Benji. Let me look at the data set over here. Let me look for SF. SF is right here. There it is, Benji. That looks good. And then the last person is Pat Mish. Okay, let's verify. So go here, go to the bottom, and Pat Mish. Perfect. So it looks like we successfully kind of filtered our for loop because of this constraint. Okay, so this is part of what the homework is asking for. Basically, you're going to have to choose whatever team and go through that team, calculate statistics for them. Okay. Let's see. Any questions about this so far? Okay, once again, this is just a playground cell. It's not actually the solution. It's really just the practice navigating the data. That's really what we're doing here. Okay. Now let me see what else we need to do. We are going to be calculating BMI. This is a measurement. It's pretty much a fancy equation of your weight divided by your height. That's pretty much what it is. It's a little more than that, but yeah, that's pretty much what it is. The BMI stands for body mass index, and it represents some feature of you. You can calculate BMI based off height and weight. Like basically the numerator is the weight, and then the denominator is the height. So that's pretty much that. For example, here, if you're not sure what BMI is, let me just Google up BMI calculator. So here's a BMI calculator. Pretty much you put in your feet, height in feet and inches, and then in your pounds, and it'll tell you a certain number. I'll put mine here. And then I think I'm like 130. I'm not sure. So my BMI, oh sweet. Okay, cool. My BMI is 21.6. This is once again a measurement. Don't worry about these categories here. I think using BMI as a health thing is kind of controversial. So let's just think of it as a number. So don't worry about these categories things here. This number doesn't really represent your health. Okay, let me go here. So yeah, people see what I mean. You can calculate BMI with two features, and the MLB players, each player has some features here. In particular, there's these height and weight. These height and weight, with the data set given, this height represents the inches, and then the weight represents what's it called? Pounds. So since we're using the US metric system, it might be necessary to convert into certain things. So no, you don't have to worry about the conversion, but basically I'm saying that we need to use this second formula here because the original formula assumes the metric system. But since the data is given in the US system, then we have to pretty much convert things. So that's what the second equation is doing. All right, let's help people out with calculating the BMI. So we need to calculate the BMI of each person because that's how you get the average. So yeah, folks can do the average later, but let's start with BMI of everyone. Like, let's say that for every person, maybe I wanted to print their BMI as something. So let's say BMI is, and dot dot dot. I'll fill this in later. So for now, we'll see. Let me scroll up. So for each person, BMI is blank. Let's fill it in. So each person, you can maybe imagine that we'll do an equation where the BMI is equal to something, or more specifically, the profile's BMI is equal to something. This calculating the BMI involves two variables, the height and weight. So before I do that, let me extract the height and weight. So we need to grab this value, this key value pair, and then this one over here. So I'll go ahead and extract it in two separate variables. I'll say height is equal to something, and then weight is equal to something. In particular, we need to grab the value in the profile dictionary. So this is profile height, and then this next one is the weight. Okay, before I calculate the BMI, let me just make sure these numbers are correct. I know people might be getting tired of sanity checking, but it's actually a pretty good habit to sanity check things along the way. So height is, let me put this in an F string actually. Height is this, weight is this. All right, let me test this. Press play. I need to scroll up a bunch again. There it is. Cool, this looks good. Height is 71, weight is 20. That looks fine. Next person, 72, 223. Looks good. Great. It looks like we're extracting everyone's height and weight correctly. And yeah, now we just need to use these two variables and convert them. I mean, put them in the formula. The formula is given up here. Take it's pretty much the weight divided by the height. So it's right here, profile BMI is pretty much the weight divided by height. But it's a little more than that. The denominator is squared. So you can square it with this power operator in Python. This is saying the denominator will be squared. And then very important, make sure to convert these variables to the kilograms, the metric system. And yeah, we can see that up here. But basically, since we're in US, we need to multiply by these constants in order to convert them. So I'm gonna go ahead and use this. Let's see, times 454. So the weight, this weight needs to be converted to kilograms. So multiplying it by 454 will do that. Height, this is currently in inches, and we need to convert it to meters. So to do that, we multiply it by 0.0254. Okay, great. So there it is. We calculated the profile BMI. Let's go ahead and print this to make sure it's all good. So I'll go ahead and print it over here. Print, just kind of sanity checking things. BMI is, make this an F string. All right, let's test this. So press play, and okay, it looks like I failed somewhere. I got an error. So let's investigate what's going on. Well, we did get 2 print statements working. It looks like this first print statement was successful, and also the second one. So yeah, but basically we were able to iterate once. We successfully did this line, successfully did this, and then failed right here. So this line failed for some reason. In particular, the Python is pointing at this equation. It's saying can't multiply sequence of non-int of type float. If you're curious what's happening here, it's pretty much saying you can't multiply a string with a number. That's pretty much what it's saying. It's kind of hard to see, but all of these features are stored as strings. Yeah, so this 71 is technically not a number, it's a string. And in Python, you can't really multiply strings by like a decimal here. So you're pretty much seeing this right here. Let me pull up a Python terminal. So here's a Python terminal. You're pretty much seeing this, like 71 as a string times 0.454. This is a string multiplied by a float. This gives us a error. It says can't multiply sequence. So I think what we were trying to do is convert the string into an integer, and you can pretty much do that by using this conversion thing, str. I mean not str, float. So basically this string gets converted to a float, and we'll properly do the calculation. Okay, so let's go ahead and apply that right there. We pretty much need to convert these weights and heights from a string into a float. You can do that down here. I'll probably do it as early as possible up here. So I'll convert this string to a float, and also with here. Okay, cool. So now these height and weights are actually numbers, meaning we shouldn't get this error anymore. Okay, let me test it. So press play. I gotta scroll up again. Scroll up. Okay, cool. Let's see what's happening here. Let's see. So looking at the first person in the SF team, let's sanity check this BMI over here. The Benji's BMI turned out to be 30.7. You know, let me round this off. It's kind of ugly. No, I'm not gonna round it. I'll just leave it. Let me sanity check this number. You could use a calculator or whatever. So I'm gonna use this calculator here. Let's see. So Benji has a height of 71 and the weight of 220. So let's see. So how do I represent 71 inches? 71 inches. Let's see. Oh, okay. I gotta convert to feet. So wait, hold up. 71 inches. 71 inches is 5 feet 11, right? Is it 5 times 12 is 60? 71. Yeah. Okay, this should be 71 inches. And then the weight is 220 pounds. So let's put 220 here. 220, and then I'll calculate it. So press calculate. And over here, it looks like the BMI is 30.7. That looks about right. So the BMI 30.7. Cool, looks good. Let me sanity check one more person, just like a random spot check, just to make sure we didn't get lucky. Because you know, sometimes your first one could be right, but then your future loop could mess up. So just let me sanity check this last person here. Pat Mish. Okay, this person has a really low BMI. I mean, not really low. It's lower than most people's. Let's see that their height is 74 inches. Let's do that. 74 inches. 74. That's 6 feet 2. Okay, so 6 feet 2, and then how much pounds do they weigh? They weigh 170 pounds. 170. And then calculate. Looks like their BMI is 21.8. And let's check. 21.8. Looks good. Great. So we sanity checked the first and last person in this San Francisco data set. Subset. All right, people cool with this so far? Okay, let me get rid of some print statements. Once again, these are just to help us visualize what's going on. I'll get these. I'll just leave the BMI out because this whole assignment is working with BMI. Okay, let me press play again so the looks a little neater. Okay, cool. So now we get a bunch of BMIs that represents for each player. Okay, any questions about this so far? I might as well get rid of these too. Okay, any questions about this? Okay, nothing. All right. So with that in mind, you might be able to calculate the average BMI now. I'm not gonna go over this. There's a lot of different ways you can go about it. So folks should try it out. Try to see if you can calculate the average BMI given all of this right here. Basically, you have to sum all of them up and divide them by the length, or how many players there were in that team. And there's many ways you can go about it. Okay. Let's see. So there's the BMI of everybody. Let me see what else. Yeah, so that's pretty much it. If anything, you got to calculate the average BMI and also find the smallest and largest players. For this assignment, we're defining the smallest and largest by their average BMI. So this is defined by their BMI. Some people might define these as their height, but no, just for this assignment, it's defined by their BMI. Okay, let's. So yeah, pretty much the end goal is to have a few print statements. Like, oh, I chose this team. So right here, you should end up with something like in the very final solution. Just say, I chose the team, some team. I'll just leave it as ... to do. I chose a team. Hold on, let me get rid of these print statements. Print statement, and press play again. So yeah, the end goal is should be able to read what team you chose and the average BMI. So the average, their average BMI was because this is an old data set. So was to do. Let me press play here. Right, so it should say their average BMI was something, and then what else? The min and max as well. So the biggest player is to do, and also the smallest player. Yeah, so that this is pretty much the end goal of the project. So you might want to make some variables that keeps track of who these are. I would take a look at the beginning of this recording. in the beginning of the recording, we did a very simplified example in the data statistics. So if you fully understand this smaller example, you might be able to apply it to this Major League Baseball players thing. Okay, any questions about this project so far? Okay. Yeah, it should be a cool one. Should be a cool one. Okay, I think that's about it for today. Really just wanted to give some pointers to this project. It's one of the harder ones. If you're having trouble with it, please let me know. Okay. Thank you all and have a great day. Bye.